Welcome viewers to Gateway Learning Center. I'm your tutor, Chandanathan. Today we're going to look at physics, another topic, radioactivity. Now radioactivity won't do it as in O, so only focus on a subtopic which is half-life. So we'll discuss how to calculate half-life in all its angles. Therefore, we need to understand the term half-life. So when I'm dealing with half-life, we know that half-life, by definition, we can say is the time taken by radioactive sample can be mass, radioactive sample to decay to half of its original value. So that's a simple definition I can put under half-life. Now, the other thing to understand under half-life, we need to know that half-life can be calculated as half-life is equal to time over number of disintegration. And this formula, in most questions, you find that it cannot be used the way it is. So you need also to understand this part. So 1 over 2 to the power n is equal to the original or the initial sample over the original sample. So the initial sample over the original sample. So this is used as 1. Then the value we're going to get here. So the instance of using this one is to find this value of n. After you look for this value of n, the number of disintegration, then you fuse it into this formula. Therefore, you can answer or calculate for half-life. So once you understand these two formula, meaning that half-life will be very easy for us to calculate. Then apart from this, some questions, they don't involve the using of this overall formula, but they directly depending with what the question demanding us to do. So let me put up a question from 2020 paper 1, then we see how we can use this formula. Then again I'm going to get another question which will not require this formula, so that at least by all angles we are able to understand and how to approach a question. Okay, so this is the question which we'll use as an example. Now, when you look at the question, we are saying that a radioactive material gives a count rate of 8,000 counts per minute after 20 days. So after 20 days, it gives a count rate of 500 count per minute. What is the half-life of this material? So from here now, we know that we have been given the count rate. So before we use the formula for half-life, we need to find the values of this count rate. So we'll say 1 over 2 to the power n is equal to the initial over the original. So from here, we'll say initial, we have 500, then we have 500 over 8,000. So you can cancel, you can cancel, you can cancel, you can cancel. So 5 into 5, it will give us 1 over, then 5 into 8, what are we getting? So 5 into 8, this is physics, we can use a calculator. So it will give us 16. It will give us 16. So this is the value we have calculated for count rate. Therefore, we're going to drop down this part to say 1 over 2 to the power n. Then the principles of indices. The principles of indices will come now here, where we're going first to cross multiply. Then we know that 2 to the power n is equal to 16. So I want to get the value of n. Remember mathematics paper 1, what we taught was the basis for us to know the value of this variable, which is the power of these two. We need to ensure that this number, we find a number which can give us this base. When that number is multiplied, it can give us back 16. So we'll say 2n is equal to 2. So how many times can we multiply 2 to get 16? So it will give us 4. So these 2 and these 2 can cancel. Now the bases are same, so we can cancel them. Then you say n is equal to 4. So we have found that n is equivalent to 4. This is not all. Now we come to half-life. So therefore, HL is equal to time given over n. So time, you have 20 days. So 20 over 4. And our answer will be 4 into 20, it will be 5. So 5 days was the half-life for this radioactive material. So basically, this is what you need to do. Don't make a mistake where this big number goes on top, then the smaller number comes on the bottom. Because when this one goes into this one to give you a perfect number. So always, the smaller number which remained after certain activity should be on top, then the original amount should be on the bottom as a denominator, then this one small number as a numerator. Then you do mathematics. After you find the fraction of this one, you equate your fraction to this value. Then you find the value of n. After finding the value of n, in step 3, you now introduce the formula for half-life. So basically, this is what we normally do whenever dealing with half-life. Then this question, strictly, it comes on section A. The first section, which has multiple choice, this is where this question normally comes to. So let's look at another question, which now will not involve this formula, but it will involve another way to calculate it. Okay, so this is the second question. So from the past paper, of course, the radioactive element thorium-234 as the mass number and 90 as the atomic number, with a half-life of 24 days. Then this one decays by emitting a beta particle. How long means time. How long will it take for 1 gram of thorium to decay to 1/8 of the mass? So you can see that in this question, it is different from the first one which we did. This one, it is not involving the count rates. This one is straightforward. Now, the approach of this question, the first thing is that this 1/8, for you to be on the safe side, you need to convert it into decimal numbers. Once you convert this one into decimal numbers, then it will be very easy for you to know the answer in a very shortest period of time. So since you have 1 over 8, so 1 over 8, when you change it into decimal numbers, it will give you 0.125. So we know that 1 over 8 is equivalent to 0.125. After that now, we will say what have we been given in the question? What have we been given in the question? So in the question, we have 1 gram. So we'll say now, how many half-lives can it take 1 gram to reach at this number, or to reach at this number 1 over 8? How many half-lives can we use to reach at this number? So since this one has a half-life of this part, we need to understand that when half-life is given, it is the same half-life which we use to do the calculation. So here you find that now, since you have 1 gram, so we'll say 1 gram, the half of 1 will give us 0.5. Then here we're going to put 24. Since this 24 days is the half-life given in the question. Then again, the half of 0.5, will give us 0.25. Then you put 24 days as the half-life given in the question. Then until we reach at this number, then we're going to stop. So from here, the half-life of 0.25 will give us 0.125. So this number and this number now, they are tallying. Hence, we know that it has taken 3 half-lives for 1 gram to reach at 0.125. Therefore, we'll say 3 times 24, or you can say this plus this plus this. So 3 by 4, it will give us 12. So you write 2, then 1, then 3 by 2 to give us 6 plus 1, 7. So 72 days was the answer. So this question, this is the approach. Again, there is another question which cannot be approached in this manner, but it is similar to this one. We can do the same things. So 24 days as the half-life should be put here. Then don't confuse to say, why are we using 24 here? 24 has been given there. Then the other thing is, the half of 1 gram, should not be confused with this half-life which has been given in the question. This half of this one, it is independent from this one. So this is how we do questions which involves this type of questions. Then let me look for another question which is similar but maybe different in terms of calculation. Okay, so this is the third question as our last example. Then I'll give you the question which you can try. So you can copy the question, then you try. I can pause the video, then you try. Thereafter, we compare the notes. So from the question now given, we are saying, given that the half-life of thorium is 52 seconds, how long will it take for the activity of the thoron sample to be reduced to 1 over 64 of its initial value? So let us identify what have been given in the question. Given that the half-life of thorium So half-life, if we can get our data, you know that half-life, we have 52 seconds. And what else? We have the fraction. So the fraction, we have 1/64, which will convert into decimal numbers. So how long time, how long will it take to be reduced to that? So what I'm going to do now is that we'll convert this number into decimal number. So if you divide 1/64, we'll get something like this: 0.015615625. That's what we're getting. So 15625. So I've converted this number into a decimal one. Then from there, the next thing we're going to do is to identify which initial number in the question which has been given. Now we look into the question, you will discover that in the question there is no initial number like the previous one where 1 gram was given. But in this question, there is no number which has been given as our initial value. So this is where the trick part was, because if the initial number is not given, it will be very difficult for a student to see where am I going to start from. Now let's simplify this one. If the initial number is not given, put that point in mind. If the initial number is not given, just know that it will start from 1, even if 1 is not given. So we are going to get 1 as our initial point. So we'll say now 1, then we put 52. The half of 1, it is 0.5. Then again, the half of 0.5, so you have now here, we'll put 52. So I have 52. So we'll continue to reduce the number the way we did at first. So 0.5, the half of 0.5, you'll find that to give us 0.25 until we reach at this number. So from here we'll put another 52, and the half of 0.25 we divide by, so 0.25, then we divide by 2, we're going to get 0.125. Then we are not yet there, so we'll keep on. So from here, the half of that number, so let me put my 52. Don't forget to put the number here, the half-life in the question. So I have 0.0625. Then if you're not yet there, keep on going like this. Then 52 here. So the half of that number, again, we are getting 0.03125. So not yet. So I'll put my 52. Remember, this 52 I'm using is the one given in the question. Then from there, we'll also do the half. So it seems like we are there. 0.015625. So this number is the same as that number. Now, having done this, we'll say now We have 1, 2, 3, 4, 5, 6. So we have 52 half-lives from the initial one to reach at this point. So for this thorough sample to be reduced to 1/64, we need to move 6 times as our half-lives. Therefore, the answer will give us now 6 times 52, which will be equivalent to 312. So 312 seconds. So 312 seconds was the number which was needed for us to move from the initial value here up to this value, or which is equivalent to this value. So this is how we do the calculations. So the only difference with this question, don't get confused. If the initial value is not given, just know that you are starting your calculations from 1. But if it is given, well, that question is simple to solve. So don't forget to subscribe to our YouTube channel, Gateway Learning Center. Then anything you want in terms of more explanations, more examples in different formula you can use, you can leave a comment in the section below. Then you're going to interact with you. So I'll leave some questions from the past paper. Then I'll just write the year of the past paper and the question number. Then you can try at your own time. If you find that those questions would be very challenging or difficult to you, you can comment on the same section below. Then we revise those questions, we answer together. So for today, under radioactivity for section A, physics paper 1, exam question. These are the questions and how they are being brought. Then for other calculations under half-life, meaning for sections B and C, where a graph is needed to plot, then you find the half-life. We'll also look for that in the next video. As for now, we end here. So let me put some question numbers, then we say it as a day. Okay, so that is the question. We'll see 2023 GC paper 1 2023. Check from that paper and see how you can answer the question and half-life from section A.